Hello, college biology. It's been a while since I posted a video, but here we are, and we're going to discuss the basics of enzyme activity. So, here we go. First thing, what do enzymes do? Well, they speed up chemical reactions. Our cells, our bodies, living things need to do chemical reactions oftentimes faster than their natural rate. We need to do chemical reactions at the speed of light, not at the speed of, unassisted physics sometimes. And so, how does that work? Well, let's look at the anatomy of a chemical reaction. We have reactants. These are the molecules or atoms or particles that are going to be the starting material of the chemical reaction. And we have our products here. These are going to be whatever is made at the end of the chemical reaction. And we have a transition state. Now, the transition state is like that middle point where they're all kind of jumbled together and they are becoming the product. They're making that transition. But there needs to be energy invested to get to a transition state. These two molecules, if they don't have enough energy, just free energy about motion, kinetics, if they're not bumping into each other hard enough, they're not going to be able to get to this. So this graph is a visual representation of that need for energy. We have this is our amount of energy, and we have the amount of energy that is stored in the reactants. Then, if they gain energy, maybe this is because they have kinetic energy and there's a collision. If they gain energy, that will allow them to be forced into the transition state. And once they're in the transition state, well, they will complete the reactions, and they will become these products. And this particular reaction, they will lose energy to the environment, and there's less energy stored in the bonds of these products than there is in these reactants. So what do enzymes do? Well, since they're grabbing molecules and through their isomerization and shape changing, kind of bashing the molecules together, the molecules themselves don't have to have as much kinetic energy to do the reaction. So that is what this is. This is what the amount of activation energy that is required if we have an enzyme. So this is how much energy gets saved. Well, if you're saving energy, that means that you can conduct the reaction sooner. You need less energy to get it done. So it takes less time for that energy, for that reaction to occur. So reactants require less energy if you have an enzyme, and then you make your products. So they speed up the chemical reactions by reducing activation energy. Now let's take a look at how that works. We have our substrate. The substrate is the molecule or molecules being altered by the enzyme. And the substrate is going to be attracted via polarity to the active site of the enzyme. This is the region that binds to the molecule. Well, once here, they will undergo their chemical reaction to make a product, and those products will be released. Oh, it's hard to see. Let me scooch a little bit. So those products will be released. And so those are some major vocabulary words we need to be comfortable with. Substrate, the particles that are being altered and are attracted to the active site. The active site is the location on the enzyme where the substrate is attracted and the reaction occurs, and the products are what the substrate becomes, which are released. We have a little more. We can look at some optimal conditions for enzymes. Since enzymes increase the rate of the chemical reaction, we call that the rate of enzyme activity or the rate of enzyme action. Many enzymes, almost all, not all, but almost all in the human body, have a primary temperature of about 37 degrees Celsius, which is where our body temperature is. These enzymes evolved to function in our chemical environment, and in our chemical environment we're generating heat, which is 37. If you look at another organism, this might not be the peak temperature, and so there's a range of temperatures on Earth about which enzymes are, where they are optimal, but for most we are at about 37 degrees. That's where they're optimal, and for the rate of enzyme action, it's also dependent on pH. A pH of 7 neutral is optimal, so if you're ever in this range, in the 6 to 8 range, your enzyme's probably doing pretty good. We've got a lot more to discuss about enzymes, but I don't want to make this video forever long, so we'll stop here and we'll do a part 2 later. I hope this helps. Struggle well.